Today's lab is reactions in aqueous solutions. So you're looking at metathesis reactions and net ionic. So you should be able to write a metathesis reaction. Remember from the chemical reactions lab that they have that general form AX plus BY yields AY plus BX. So you should be able to predict all of those products of metathesis reactions. Also, you want to remember those exceptions to that kind of general form. So you have the ones from the chemical reactions lab, sulfuric acid, H2SO3, which does not exist in aqueous solution. It decomposes to sulfur dioxide and water. The other one that you saw in the chemical reactions lab was carbonic acid, H2CO3, and that decomposes to carbon dioxide and water. So there's actually going to be another chemical that doesn't exist in solution here. That's going to be ammonium hydroxide, which is NH4OH. So that decomposes to a gas. The gas in this case is going to be ammonia, which is NH3, and water. So remember those exceptions when you're trying to predict the products of your metathesis reactions. So you should be able to predict the products of your metathesis equations. And from those products, you should be able to write molecular equations, complete ionic equations, and net ionic equations. So the molecular equations, everything exists as molecules, just as they are, just like the chemical names, you don't split anything up. The complete ionic equation kind of gives you a hint of what it should be like. You should split everything that's in aqueous solution into ions. Okay, remember that those aqueous solutions exist as ions, not necessarily that whole compound together. The only thing that should be broken up into ions are the things that are aqueous. So if it's a gas, if it's a solid, if it's a liquid, those things should not be split into ions. They don't exist as ions. Only aqueous substances exist as ions. So in your book, we are going to do reactions 1 through 4, 10 and 11, and 15 and 16. So I have all of my chemicals, I have test tubes ready, and I have all of my waste containers ready, because you want to make sure that you put your waste in the correct container. So we will start with reaction 1. That's going to be copper 2 sulfate and sodium carbonate. So the directions and the procedure say to add about 15 drops of each solution to your test tube, and then you're going to need to make observations. So you want to make the observations on your report sheet, and then you can go back on your report sheet and write in your molecular equations, complete ionic equations, and the net ionic equations. The net ionic equations I didn't mention before. In the net ionic equations, you have just what's happening in that reaction. So any thing that exists on both sides of the equation, that's exactly the same. So ions that exist on both sides of the equation that are exactly the same will cancel out. So in a net ionic equation, it's just showing you what's undergoing reaction. So you'll get a lot of experience writing molecular, complete ionic, and net ionic equations. So we will start with reaction 1. Again, that is copper 2 sulfate. So I have my copper 2 sulfate here. You can see that it is a blue solution, and then we are adding to that sodium carbonate. Sodium carbonate is also a solution. So every single reactant that you have today, every single reactant is an aqueous solution. So you don't have to guess about the physical states of those. They are all aqueous. All reactants in this lab are aqueous. Okay, so I'm going to start with my sodium of the copper 2 sulfate. Copper 2 sulfate. Okay, we'll kind of shake that up just so that all that stuff in there reacts. But you can see that now our solutions have turned cloudy. Okay, so I'll put a piece of paper behind it so you can hopefully see it a little better. Now this solution is cloudy. So you want to think about what kind of observations you should make for metathesis reactions. How do you know that a reaction has occurred? So we'll come back and look at this in a little bit so we can decide whether a precipitant formed, do we have something else happen? Moving on to reaction 2, we're going to do copper 2 sulfate and barium chloride. So what I'm actually going to do is I'm going to go ahead and put my copper 2 sulfate in both these reactions because our next 2 reactions do involve this copper 2 sulfate. Okay, again, all of these solutions here that we're using, all the reactants are solutions. They're also see-through. So you can see that before I added anything to my copper 2 sulfate, it's blue, but it's see-through. Okay, you can see through them. So all of our solutions, one of them is blue and see-through. The other ones are all colorless, clear liquids. Okay, so here, now we do not have a colorless solution. It is very cloudy in here, so remember what cloudiness indicates to you based on your observations. So this is copper 2 sulfate plus barium chloride, and we'll let this kind of react and settle and look at it in a few minutes. So I'll just set that aside. Okay, so it's not see-through anymore. This solution is not see-through anymore. This is the copper 2 sulfate plus sodium phosphate. Okay, so this is not see-through anymore. So again, we'll let this settle and see. We'll come back and look at it in a little bit. Okay, moving on to reaction 4. Reaction 4 is sodium carbonate plus sulfuric acid. Sodium carbonate, which is Na2CO3, plus sulfuric acid, H2SO4. So you are responsible for knowing, if I tell you a chemical, knowing what that formula is. Where if I give you a formula, you should be able to tell what the name of that compound is. So we are doing reaction 4, and this is going to be sodium carbonate plus sulfuric acid. So I don't know how well this is going to translate to video, but there are bubbles being formed in this reaction. So there is a gas forming. So remember what you would expect to see if you have a gas that forms, what kind of observations you would make. Okay, so that is sodium carbonate plus sulfuric acid, and we had a gas form. We also have this clear solution, so there's no precipitant, no solid forming here. But we did have a gas, okay? There were bubbles that formed in this solution. If I shake it. Now we want to do reaction 10. So we're going to do 10 and 11, 10 and 11, and then 15 and 16. So reaction 10 is the reaction between hydrochloric acid and sodium hydroxide. Reaction 10 is a reaction between hydrochloric acid and sodium hydroxide. Okay, so let me just shake it up a little bit, make sure that reaction happens throughout the entire test tube. This is sodium hydroxide and hydrochloric acid. Okay, so it doesn't really look any different. So, however, there has been heat. It feels warm to the touch. So when I grabbed it down there on the bottom of the test tube, it feels warm in my hand. So remember what indicates a chemical reaction happening. So just because we can't see anything that happened directly with our eyes doesn't mean that there wasn't a reaction happening. So you want to make sure that you think about any types of observations that would indicate a reaction happening. So specifically for metathesis reactions, there were 3 types of observations, or 3 ways you know that a reaction has occurred. So go back, look at your book, think about what those 3 ways were and what happened in this reaction between hydrochloric acid and sodium hydroxide. This is not a no reaction, okay? There's only one no reaction that we're gonna look at today, and this one is not it. Okay, so there is a reaction happening, so you wanna think about what did happen in this test tube here. Okay, the next reaction is number 11. This is ammonium chloride, NH4Cl, plus sodium hydroxide. So we're using a saturated solution of ammonium chloride. So in this dropper bottle, it's really hard to see, but there is solid on the bottom of this solution. So this is a saturated solution. No more ammonium chloride can be dissolved in this solution. We do want to use that saturated solution. I'm just shaking that up, make sure that reaction happens throughout all of the test tube. So there's nothing overtly happening that's very visual. You can kind of see it mixing. Maybe there's a very, very fine bubble in there. The test tube kind of got cold, feels a little cooler than one of the solutions that I put in there. And if I waft this, so if I want to observe the odor of this, I would wave those vapors towards my face. So here's where it comes in handy to be able to predict your products of metathesis reactions before you even looked at the reaction, or if there was a reaction happening. So if you're able to predict those products, you should know what you're looking for. You should know, kind of have an idea of what those observations should be when you do this. Okay, so there's not a whole lot happening here that you can see, but for this particular reaction, we're going to use a piece of litmus paper that will tell us if we have a base present. So I'm gonna hold it in the very top of my test tube and see if that color changes. So we're using red litmus paper, and that red litmus paper in the presence of a base turns blue. So I don't want to drop it into my solution because I know that I did add sodium hydroxide, which is a base. I just want to hold it in the top of the test tube to see maybe if there's any gases. If I wanted to observe the odor of this gas, I could waft those vapors towards my nose. If I didn't smell anything, then I'm going to use this red litmus paper to see if I have anything, any basic gases that have formed. Okay, you can definitely see it turn blue here. I'm just holding it inside the test tube, kind of shaking that up. It's definitely turned blue now. So that does indicate to us that we have a base that's formed, and that base is a gas. So remember those exceptions remember the exceptions that we talked about at the beginning of that AX plus BY yields AY plus BX. Ammonium hydroxide was one of those exceptions. So what does ammonium hydroxide actually decompose to in solution? So it decomposes to a gas. That's a basic gas. So we can see that test tube, our litmus paper turned blue, and that gas is ammonia. Moving on to the next reaction. This is number 15 in your book. on your report sheet where you're recording observations, writing out the equation, the chemical reactions here. Number 15 is lead 2 nitrate. Lead, so your book actually just calls it lead nitrate. It is lead 2 nitrate. Lead can form 2 positive ions and 4 positive ions, so you do want to make sure that you say what kind of lead it is. So we are using lead 2 nitrate, and we're going to react that with sulfuric acid. Okay, both of these solutions are going to start out as clear colorless. This is the lead nitrate. This is my sulfuric acid, so they're both clear. So I'll let you see what happens when you mix them together. Okay, so that happened pretty quickly, pretty dramatic change there. Both these solutions were clear, and now it is obvious that we have some kind of white solid in there. So we have a white solid. Okay, and then the last reaction is number 16. That is our potassium chloride plus sodium nitrate. Potassium chloride, KCl, a colorless clear solution, plus sodium nitrate, another clear colorless solution. So okay, so just the initial observation is I don't see anything changing. Okay, let me shake it up a little bit, make sure that reaction happens. Just looks like one solution, nothing in there, no bubbles, no mixing, just 2 solutions. They must be soluble, there's no layers or anything. So this is sodium nitrate plus potassium chloride. So there is nothing obvious that has happened here. There's no temperature change. It still feels exactly the same. So make your observations on what happened here, and then you can write your equations as well. Remember, if you do have one that's no reaction, you can write a molecular equation as well as a complete ionic equation, but since there's no reaction, there should be no net ionic equation. Everything canceled out in a no reaction. All of the ions on both sides of the equation are the same. So that goes through the reactions. You should be able to get some observations for 1 through 4, 10, 11, 15, and 16, and then be able to write your molecular, complete ionic, and net ionic equations. And just to kind of go through the beginning ones again, or any that look like they made something, maybe a solid precipitant, we'll kind of look at those test tubes one more time to see if we do definitely see a precipitant. Okay, so I said that we would come back to reactions 1 through 3 and look at those again. So this is reaction 1. So I don't think that the reaction kind of went through the entire test tube. But you can definitely see that it's not see-through. Okay, we cannot see through this solution. There is a solid that formed. So from your knowledge of metathesis equations using the solubility rules, you should be able to predict which one of those products is the solid. Remember that there is a copy of your solubility rules on page 161, I believe. Yes, page 161 are those solubility rules, so you can predict which one of those products is soluble and which one of those products is a solid. So looking at reaction 2, this precipitant fell nicely to the bottom of our test tube. Okay, so there's some white. There's some white solution down, or white. This is reaction number 2, copper 2 sulfate plus barium chloride. You can see that there is definitely a precipitant that fell to the bottom of our test tube. So again, using your solubility rules, predict what that product is and what's still in solution. Okay, so you can see that. And reaction 3, copper 2 sulfate and sodium phosphate. We want to see if there was any separation. Did a precipitant form? So yeah, there was probably a lot of precipitant that formed here, and it didn't all settle to the bottom in that time that we gave it. There is definitely a solid product in here. So you can kind of see up here is see-through, it's solutiony, and then down here it's not see-through. There's all that solid in there. So that was reaction 3, copper 2 sulfate and sodium phosphate. And then the last one we'll relook at is number 15, lead nitrate and sulfuric acid. Lead nitrate and sulfuric acid. So there's pretty obvious that there's solid on the bottom here. And that was pretty obvious when we did the reaction, that there was some white solid that formed. So again, you should be able to use your solubility rules to figure out what that product is, and what is also in your what is in solution. So what's aqueous and what's the solid. So now I want to make sure that I use my waste containers. So I have a waste container for each of my reactions. So I do want to make sure that I put all my waste in the correct place. Then I will clean my test tubes, leave them to dry. When you clean your test tubes, again, you want to make sure that you actually clean it. So dump all of this out, get as much of the solid and liquid out of there as you can, and then put some soap in it and brush it out until it is clean. So sometimes people leave a lot of test tubes dirty, so you want to be able to be sure to know how to clean these test tubes, how to clean glassware in general.